Okay, one other aspect of these multi-index containers that is kind of interesting is you can query into them, almost like they're a database in some sense, which is actually how EOS uses them. So you'll be writing kind of quote-unquote queries against the data that's on the blockchain that you've stored on the blockchain in your smart contracts. So I wanted to throw a little quick tutorial kind of showing how that works here. And in fact, like the Boost libraries do the same thing here. They take the employee sets that we created originally, and they just like deep dive deeper and deeper and deeper into these multi-indexes. And that's part of the reason why we went through the trivial examples. Like obviously part of it is like get familiar with the data structure, but the other part is now we have this mutual understanding between you and I is like, okay, what's in this data, how does it act, that kind of stuff. We have a good frame of reference. So in order to query into these, you do very much the same thing we did previously up here, where we were getting the index and then iterating through using that index. Essentially, after you've got this index, you can kind of treat the index basically like the STL data structure that it's supposed to be representing. In this case, it's a set, right? You can kind of treat it exactly like a set. In this case, set has a find operation. So in this case, we have this name set operation find Bob. We're querying the set index, the name index that I've called it here, to get the Bob. The question kind of becomes, though, let me comment this out really quickly. But the question becomes, which Bob do we get? That's might be problematic, right? We actually get Bob 1, right? Okay, which is fine. But what happens if we wanted Bob 4? I was going to say the second Bob. I mean, it's also the second Bob 4, right? Remember from the original video. What you can do, like I said, we can treat these these are iterators, right? They're iterators into a set, essentially. So we can treat these exactly like iterators and increment them. So what happens when we increment Bob here? We actually get, sorry, this takes so long to compile because I'm recording the videos at the same time and this computer isn't very good. We get Bob 4, which is pretty nice. It means like, okay, we know who the next Bob in the name index is. It's actually Bob 4. We'll give you that Bob. We can keep incrementing here, and now the Bob, the variable name Bob is not going to apply anymore, right? Because we're probably not going to get Bob again after incrementing, and in fact, we get Susan too. So that's generally how you can find things inside these multi-indexes, really using any kind of select statement at this point. I mean, you can kind of treat them like columns. It's almost like NoSQL, right? You just throw it, give me all the Bobs, essentially, and they get returned to you kind of as an iterator. But another thing that's interesting is like you can take this SQL idea one step further, and rather than just like finding and then iterating like we're doing here with Bob, you can actually select the top and bottom range using the iterators. Like they'll point to the top and bottom for that particular select. And the way you do this through the documentation, they kind of show you a couple different ways of doing it, and then at the very end they say this is probably going to be the easiest way. Except for, we'll dive into one more small example after this, but that one's kind of specific to the example that they use. This one's more general, right? So we have this comp ID struct, essentially, where we create two operator overloadings for the Booleans. And this allows us to kind of filter the top range and the bottom range of the data. So what I would do if I was you is I would just like get used to throwing this struct up there anytime you want to write a filter type query on this multi-index. And what this will allow us to do is get the upper bound and the lower bound for the multi-index of the query. In this case, let's say I only want to print out employees between 0 and 3, right? What we can do is print out the upper bound query and see what gets returned to us at the very top. And the reason I'm doing this is this will tell you the last element essentially that you'll be printing out. So if we did a for loop through here, again, these are iterators, so you can treat them exactly like any other iterator from that STL library. We can go through and print out every employee in the multi-index after having select the top and the bottom. So here, this is what we're doing. Let me comment this out so that we don't confuse ourselves. So now we're just doing a simple select, filter select, and then iterating through. And you'll see, since we filtered from 0 to 3, those are the only ones we're going to print out are 1, 2, and 3. You'll notice that the select isn't inclusive, right? The top, we don't iterate all the way up to Bob 4 in this case because the iterator, we hit this not equal to upper bound and we exit the for loop immediately after that. One thing I wanted to throw in here is, like, part of the reason these queries return these iterators is they make things like this for loop much more succinct, right? This is how a real C++ programmer would likely do this iteration that we're doing here, rather than explicitly calling it out like this. You can just pass it into for each, then you don't have to do anything crazy. So you make this select. Let's say we don't want to print out the last, who was it? Alice. Let's say we don't want to print out Alice in the for loop. We just pass in whatever iterators get selected out of the multi-index, and then we can do whatever we want with that employee, computationally speaking. In this case, I'm just printing it out, but obviously, you know, the world's your oyster. And as expected. Okay, we'll just keep deep diving on this multi-index because, again, it's very important to smart contract development. So the more you know about it, the easier it'll make your life. I'll see you in the next video.